Happy welcome back from spring break. Here we go with conic sections. So if you take a couple of cones, ice cream cones, whatever, and you stand them on so that the points go together. Why you would do that, I don't know, because the ice cream on the bottom one would just fall out. I guess it kind of makes an hourglass, but it does keep going to infinity in both directions. But if you take these three-dimensional figures and you cut a plane through them, you make what are called conic sections. Now, if you cut straight across somewhere in the cone, you will cut an image of a circle. If you cut kind of like you did with a circle, but kind of at an angle, you get an ellipse. If you cut and the cuts on one side go to the edge, and on the other side they go to the infinity part, they don't hit a side of the cone, you get a parabola or a hyperbola, depending upon how angled you make that cut down. Yes? Those will be on School Loop. I'm recording the notes now, so they'll be there. Do you need to understand these pictures of cones? Nah. So I'm just giving you a little bit of theory about where these come from, these conic sections. And don't even worry if they're degenerates or not. We don't really want degenerates in our school system, but these are non-degenerate conic sections. So this is just for your for you to look at here. If you understand it, fine. If you don't, you're going to see conic sections again, and in pre-cal. So when you see them again, you'll go, okay, I kind of remember what we did with conic sections in Algebra 3-4. Today and tomorrow we'll deal with the parabolas that get cut out of the conic section, which are the same parabolas you've been using. And then we'll go on to the circles and the elongated circles, which are ellipses, and then we'll get to the hyperbolas. We're going to redefine a parabola. A parabola is the set of all points whose distance from a fixed point, we call that F, the focus, equals the distance from a fixed line. That line is called the directrix. Let me show you what we're talking about. This is kind of cute. So here I am making a parabola. So the distance from this point here in the middle to the parabola that I'm sketching out is the same distance as the point on the parabola traveled straight down the red line to the black line. That's the directrix. And when that distance is always equal, you trace out a parabola. So I'm going from, you have to figure out what distance I'm talking about. The distance from the focus to the parabola is the same as the distance from the parabola to the line down below. Okay. Now, do you have to understand what that's talking about? Nah. But that's how we're defining a parabola. So we're going to work with a different way of defining parabolas via conic sections. And that it's the set of all points equidistant. You should know the definition. Okay, can you go back to the definition? Yes. Parabola is a set of all points, P, in a plane, it's supposed to say, whose distance from a fixed point F, that F is called the focus equals the distance from a fixed line, and that line is called the directrix. And even here in the notes, you if you get the hard copy notes, you can cut and paste and see that little demo for yourself, because you want to try to prove that for yourself. Okay. Bless you. So here we go. I'm gonna make myself a parabola on the XY plane. I'm gonna make one that's, we're gonna do for today, and often with these conic sections, we're gonna put them at the my earpiece is not going in good. We're gonna center them in some way at the origin, and then we'll move around their center part. So this point is still called the vertex. I'm going to have a point that is inside the parabola, and it's going to be on the kind of the same axis as the vertex. And that point that's inside the parabola, that's the point we're going to call the focus. That's just my arrows. I didn't make a right angle. That's just an arrow. That's an arrow. That's the point to an arrow. Yeah. That's just the arrow for my pointing to where the vertex is. Yeah. Directrix. D-I-R-E-C-T. Ooh, maybe there isn't an E there. Oh, there's no E here. Let me just write it over again, since you can't read it anyway, because I got to write it again. D-I-R-E-C-T-R-I-X is the line L. The directrix line is going to be, in this case, down below your parabola. And the distance from the vertex to the focus, we're going to call that distance C, is the same as the distance from the vertex to the directrix line. So those distances are the same. And that's what I'm going to need to find the equation of the parabola. We're going to center it at the origin. So my equation, this is a parabola that goes up. So that's a y equals x squared parabola. I won't do an HK and move it around yet. And where that C comes into play, it's 1 over 4 times C times x squared is the equation of that parabola. I'll show you 3 more. I could have a parabola that's going down. Can I page up a little bit? Okay. That's a y equals negative x squared parabola. It's going down. The focus is down inside the parabola. The directrix is going straight across, but it's above the parabola.